I am the stone fruit physiologist, and most of my work focuses on sweet cherries. My work addresses the key horticultural and physiological issues that the cherry industry is facing, and that changes sometimes year to year. And so we do a lot of different areas of research, and they range from issues of water use efficiency. We've looked at issues of crop load management. We've studied new varieties, new rootstocks, and a new canopy architecture for sweet cherries. It's been dubbed the UFO, which is an acronym for Upright Fruiting Offshoots. And that's the orchard that you see behind me. This is a totally novel and in some ways a bit of a radical way to develop a cherry orchard, to plant the trees, to grow the trees, in order to train the trees and develop the shoots in specific positions. So what we're trying to do here is a couple of things. First of which is to improve efficiency, and most importantly that's the efficiency of the labor inputs into orchards. Cherries are the most labor-intensive tree fruit crop. But we're also looking at improving the efficiency of light as a natural resource, the light interception by a canopy, and what the tree does with that light in order to divert it into good quality fruit. And we're also looking at improving the efficiency of other inputs, which would include pesticides, for example. We're also trying to reduce the environmental footprint of cherry production in the state. Profitability for cherry growers hinges a lot upon the costs and the availability of labor. That can account for anywhere from 40 to 50% of a grower's variable costs in any given year. It's just the people that actually pick and remove the fruit and put them into a basket and put those into a lug. And so when we can improve the efficiency of that input, we're making tremendous strides forward in terms of maintaining profitability for cherry growers. So by making things quite plainer, we're able to have the fruit accessible and really improve that harvest efficiency. But one of the longer term goals here is to match the biology with the technologies that are emerging. So we're now able to think about increased mechanization or automation of some of the repeated tasks that people do. With our preliminary tests of a fully mechanical harvest system, we've seen where we can take the costs to harvest cherries from 20 to 24 cents per pound by hand to fewer than 2 cents per pound by machine. So we see a lot of promise for this mechanical harvest system. Growers need to get an early return on investment, minimize the space between trees, fill the space quickly to get the orchard into production to recoup their costs. And so what we've been looking at is very basically, how do you do that? What are the new genetics? And then how do we manage those genetics? How do we plant the trees? How do we prune the trees? How do we manipulate growth in order to optimize the precocity and the quality and the yields of an orchard system? So we've partnered with the industry. They're planting orchards just like this, so they're putting it in their own backyard, in their own soils, in their own microclimate, with their own varieties and rootstocks, which are going to vary from grower to grower. And I coordinate a tour so that the industry comes and we visit 3 or 4 of these guys every year, these growers, and they tell in their own words whether or not it's working. What we're doing really is taking a giant leap forward in how we think about planting, pruning, training cherry orchards.